Mic check. Alright, we are live. So, so yesterday we were just trying to like get the pipeline. Get, we were working on this create PBR maps here, compute PBR maps uh, function, and we were playing with the Skype, the panorama to cube map shader and pipeline. So we managed to like get everything that was just happening to one lambda here. This is our lambda. And at the end of the stream, I was like thinking how the lifetime of these like depend on each other, because that is actually a problem if I'm going to like refactor this and come up with a design. So currently, let's see. So I'm capturing. Sorry about that. Let me take a sip of water. So yeah, currently we're capturing these from outside. So I'm using all of these to create this pipeline here. Yeah, this is my pipeline descriptor there. I'm adding up my pipeline here. That's that, and then I'm just applying this command, applying these things to the command that we went through last time. Like we know what these do, but like, am I like, can I like destruct some of these variables midpoint, like here, somewhere else, or should I just wait until the command is destructed? Because like looks like to me that the command begins here, right? And then we go through some of the changes there. This is my panorama to cube map command. This is our lambda here. I'm applying those changes to the command. I'm dispatching the command several times. Then we continue up here till we like till we reach here. This is where the command ends, and then I submit the command here. So this is where I'm submitting the command, and then I'm waiting here. So I'm assuming that like everything that was used in that command is going to be used in here. So I should not be like I should not be, how would you say, I should not be destroying them. Like here we're destroying everything. So yeah, that is what's concerning me right now. Like the way these lifetimes are going to like interact with each other, that is going to be confusing as hell. Like I would assume, like, let's say, yeah, let's start here. Like I would assume that we have like, this is my pipeline descriptor, right? Like this add pipeline would just move everything that it needed from this descriptor into that. So the descriptor can die off now, and we have everything we needed in this one single self-contained object. So these lifetime dependencies, I would look at an object like uh, in I would define one object pretty much from its lifetime. Like let's say I have a point and it has too many. Sorry about that. My throat is so scratchy. So yeah, let's say I have a pointer. It has an X member and a Y member. That's it. So why would I call this one object? Well, to me, the lifetime of X should be the same as the Y variable's lifetime. So these have the same lifetime. These probably are the same thing. So yeah, you could have something like let's say I'm gonna do it. I'm not going like they're going to be counter examples to these, but when your lifetimes are the same, you should probably start thinking maybe these are the same objects. That is why I'm kind of confused here. Like let's say this pipeline descriptor cannot be like destroyed. So this another thing is these descriptors, these are not self-contained either. So these all depend on other stuff. Let's say this compute pipeline descriptor here. We get it from this descriptor. So it's just a simple alias for one of the members of this descriptor. And what it has in itself is a shader. So this depends on a shader. So maybe the descriptor can be removed, but the shader probably not. Or the root signature. That probably wouldn't be you wouldn't probably be able to destruct that either. So I'm pretty confused. Like what what can I destroy and what I can't. Like this descriptor here, this is going to end in its lifetime. Like here, so, because it lives in the this is living in the stack. The scope ends, it is gone. So I'm pretty sure, yeah, I can destroy that. I can destroy this because these are just like probably you can destroy all of your descriptors, but the rest, the rest you probably can't. And yes, of course, it doesn't make sense. Like you would destroy the shader when before you're using it. It would someone could like argue that it wouldn't make sense. To me, that makes all of these variables when join class. And yeah, so the other day I was like reading about the chorus smells. Like let's see, let's bring the wiki. So yeah, I was going through like chord smells and some other stuff. Let me see. Ah, here design smell, anti patterns. So this code probably has many of these, like not only just one but many. So let me just check my audio. I didn't check my audio before. You're going to hear an echo. Yeah. So while that is loaded, let's go through this. So let's go through the code smells here. Duplicate code. We have plenty. And contrived complexity. Forced usage of overcomplicated designs. Well, no, we don't have this one. We don't have any designs at all. Shotgun surgery. We do have this. So if you want to change something, like if I want to like change the pipeline here, I probably have to go all over the place and change a lot of the stuff there. That is called shotgun surgery. Uncontrolled side effects? Probably yes. Most definitely yes. Variable mutations, you have lots of them. Like you have these parameters here, not there. That is scope defined, but here you're mutating. It's all over the place. And Boolean blindness, what is that? Easy to assert. No, it is not easy to assert. Oh, no. Easy to assert on the opposite value and it still type checks. I don't know what that is trying to say. Not sure about that. A large class. We are going to end up with a large class. We already have a large class, but it just has behavior, not too many members. But it is large. Feature envy. No. Yeah. That works. Right. Yeah. So excessive use of literals. I'm not going to say that we do. Maybe we do. I don't know. Not that. Psychomatic complexity. Not really. Downcast. We don't have that kind of thing here. So yeah, we do this. We have this. Like many of these variables are dependent to each other. They probably are going to be in one object as I just described here. So we pretty much have a lot of these in our code here. Too many parameters we don't. No, yeah, long methods. Every single method is long here. Excessive long identifiers, no, no. Excessive return of data, no. Long lines, not really. Let's see. Let's check our anti-patterns here. So from the anti-patterns we have color. Yeah, we do have this abstraction inversion. Uh, we have big ball of mud here. No recognizable structures indeed. I wouldn't go for that ambiguous, not gold plating either. Definitely not gold plating. And no, we don't have databases. Input clog. No. Magic push button. I saw one of these like call super no. One of these the other day just yeah, this sequential coupling. A class that requires its methods to be called in a particular order. Like everything here needs to be done in the order. Like if I change the order here, I'm probably going to crash. Not that it wouldn't work. It's just that it would crash. It would definitely crash on me. So we have plenty of these anti-patterns as well in our code. So what I'm like aiming at here for now, yeah, the list would go on if I ever just like try to get what is wrong with this code, probably everything. So I'm just trying to like firstly I need to like find out what our sequential coupling is, like what order should I call these? I don't know. I'm trying to figure it out. We've been reading this code like this 4K lines of code for 7 hours now. This is the 8th hour, and yeah, I have started like understanding the code a bit, understand how things work a bit, but not that much. So yeah, this effort here on making like a small lambdas that do uh, some meaningful thing is my attempts to like understand our sequential coupling. Also, it will help like reducing the size of our methods. That is going to fix this too large of a method. So yeah, that is what I'm trying to do with that. And yeah, so let's dig into our code here. I got few of these. So these are our returns. These are kind of our auth variables, as you would see. This is probably not our auth variable here, but since the pointer to it was returned here, the reason the pointer was returned because it was probably because it needed to send like several of these, so it's just an array of textures here. So that is what that is. So this is probably not. This is probably not not valuable. And pilot cube map pipeline. That is our auth variable. We're just creating that here. Pilot cube map pipeline. So this needs to leave like, yeah, that definitely needs to leave until I render it. Until I submit the queue, the command into the queue, and until the queue is completely like executed. So yeah, the lifetime of this object needs to supersede this method. Like it should be supersede my command's lifetime. Let's say. So there's I'm gonna try like reduce these, since many of these probably can just be declared inside. So let's say this skybox size. Let's see, this is a global variable there. I could probably define it inside, but I'm pretty sure as well that it is not a global variable. It is here, but I'm pretty darn sure that it is used many places other than this, like here. There was, so these use cases, these can come in. Here is alright, and where are we here? Oh, I probably can move them inside if I move these inside. So let's try doing that. I'm going to put this bit of code inside. Hopefully any of dependencies to that are going to cause compilers. So that's pretty safe. Compilers are the safest thing to get right now. So that bit of the code is going to get inside. So this compute PBR map, it is basically a complete pipeline renderer, everything. It creates the pipeline, it loads all of its resources, then it creates a command on that pipeline, and then it submits the command. So it does everything that we need to render one thing. So that is why I've moved to like refactoring this command, this function here, because it will give us some it will let us like see the big picture and it is actually working together. And it is a miniature pipeline, so that's better. That's good as well. You can like figure out what it does. So sampler descriptor. I'm pretty sure I will not be able to like move this sampler here because everyone likes to use this skybox as sampler. That's not good. They should get their own samplers. Maybe we will do that later. But I'm pretty sure I will be able to move this. So let me see. Moving that here too. So let's see. Have I reduced any of these usages? I'm going to now remove those. Let's see. Here we have this. Oh yeah, the token. So that is another part of the issue here. Like We have a synchronization token for our resources that are being loaded from the memory there, from the, let's say, storage. We have yeah, we have these, and these are like shared between all the resources that are going to be loaded. So what we do essentially is we tell the renderer just load everything up, we give him that token, and then we will wait on that token. That is what is stopping me from getting this here. I'm gonna put it back up there for now. But yeah, that is the kind of thing we're dealing with here. So I'm assuming these can grow as they will. Or maybe they can't. Let's see. I know this can. I know for a fact that this can grow. Or can it? No, it can't. This maybe? Yeah, I believe that one can. That one can come here. Yeah. Let's take these and let me just do a quick check. Yeah, you're fine. So my laptop's connection today is awful. So as you would assume, I have two connections here. I would watch the video on the other, on my laptop through the other connection while streaming. So that worked fine. We reduced one of our lambdas dependencies to outside. Token here. This was supposed to go up there. Or was it? It cannot go up there. I don't want it to go up there. What can I do then? Maybe I wouldn't want to do that. Let's see here. I'm gonna copy this, put it down here. So the point of this asynchronous loading is just optimization, right? You want to reduce your load time by like distributing the process over multiple threads. Like this thread wouldn't have to like wait for other stuff. Let me see. Let me see. This is our token. Let me copy our token here. So this code is going to work, but I need to like tell it directly when we are going to like wait on these tokens. If I'm going to wait on these tokens right here, I could just remove these tokens and pass a null pointer, and that null pointer would just mean that I don't want synchronization. Asynchronization is going to be blocking call. It will just block me here. So let's see. The result of these calls are going to be those textures being loaded. Skybox MIPS. Pointer to pointer. ptexture skybox. I believe that is being used here. So if I were to put a synchronization point, that would be here. And from this one, this is the pointer to pointer we have. I would need to like put a synchronization point here. So from what I'm figuring out, we need to synchronize like right here. Let me just move this down there. are we using other indices of these params? Not in this lambda. So these params can go like this. And we're going to make it param, not params. And definitely a reference to param. And we have a pointer to param here. What is this saying to me? Seemingly nothing. This could be const. I do not recommend doing any code like this. This is not this is not beautiful code. This is awful code right there. Okay, this cannot be const. So let's put our synchronization point right here for now. Like we know that we need the first texture here. This is our synchronization point. So let me see how we're rating on the token there. Rate on token. So let me just check. Everything seems fine. So one thing with this code is how like this synchronization thing works. Like those variables that we pass and wait on. Maybe that could have been just a future. This is not a safe code. Like what if I forget to wait, or what if I just like, let's say I could definitely like modify this code later on and use those variables before waiting. That could cause problems as well. So this is not a safe code, definitely not a safe code. We just counted ban any problems with this code. Safety probably is the least concern there. And yeah, we are synchronizing here. We're waiting for a token here. We know that we're using, which one is it? Yeah, that one there. So thankfully we're loading them in order. Like we can hope like that this is going to. One other thing comes to mind here to me. Like I could do something like this. My tokens there. Let's make them 2. And let's say this is going to wait on the first token. Why not? And this is going to wait on the second token. And here I only need to wait on the first token. And then right here I'm going to wait on the second token. This kind of naming with first and second, that is not a good naming. Like what I would try to do at work. Let's call these tokens. These are few tokens, not one. Alright, so yeah, I would give them name. Like why not this synchronization token? Load. Let's keep the naming convention here. Load Pana Ceramic Skybox token. That's a better name. That tells me what it does. And we don't have to use that syntax here. This is our syntax. We're going to pass this one here. Why not? Remove that. Move this here. And what is this one? Also, try to like always declare variables closest to first use. What the hell did I just do? Uh, declare them closest to their first use. So I'm declaring it here. I'm using it here. It like reduces the load, like the metal load. I don't have to like remember this from 100 lines ago. I just see it here. I see it being used there. And now that I'm using that here, right there, I am going to start waiting on it. I'm gonna wait on it here. And the name says why I'm waiting on it there. Let me copy this name here. Load panel skybox token. So let's say I am waiting on load panel skybox token. So I'm waiting on the panel skybox. That tells me what it does, and the next line just screams at me why I'm doing that. Because I'm using the panel skybox texture. So that's an improvement there. And yeah, we need another token here. So this is the texture skybox. Load texture skybox token. So we're gonna wait on that. But where should we wait on it? You see that I'm copy pasting code a lot. That is definitely true. And that is because if this was a future right there, like this would return a future to like maybe panel skybox there. Yeah, it will return a future to panel skybox, and I would just wait on that future. So I'm gonna wait on this here. So this is a bit less good than this one. Like this tells me when I'm waiting here on the next line, I'm going to read that. Okay, that is completely fine, but I'm waiting on it, on this here. Where are we actually using that? The use case is here. I could wait on it here, like on each for loop, but I don't think that would be proper. Again, I'm choosing the best of two evils. Alright, so let's go with my rule. Where is the first use for this? There. Remove it here. Reduces the mental load. And that is there. Things should be fine now. Custom data. Texture size here. So what if I were to, let's say, change the shader a bit? Why not? So let me just explain what happens here in my mind. Like I go through this code. Like I'm seeing some, uh, let's say, some values that are only available at runtime. Like the, these are not constant explorers. So to the compiler, these look like what could be available at runtime. Compiler would not be sure like these could be available at compile time. To me, they are. They are available at compile time. Let's make these actually available at runtime, and then we can simplify our shader here. Let's go to our shader. 3D shader palette cube map. We had it open from the last time. So this here. This is being done on each thread, and just to like have this work. Let me try this one. MIP size, no, not that. Let's try this one. Yeah. MIP. We're going to still need this MIP to be passed here, because we need to decide like which uh, we need to decide like which of the MIP map level we're rendering onto. The time flies today. It's 36 minutes in. So yeah, but we can like remove this line by doing what, you might ask. Let me see if this is accessed anywhere else. No, it is not. This is not accessed anywhere else. So I'm going to remove this line. Go on with it. Maybe not. Maybe not. Let me change this. I'm not going to remove that. I'm going to remove this part. And I'm going to call this MIP size. No, god damn it. MIP size. What about that? Huh? And I'm going to put this MIP size here. Then let's get back to our code here. Where is it? And I'm dispatching this command right there. So probably not a bad idea to put your structs. Oh, not there. Put your structs in a smaller smaller scope. I don't have to like remember this struct from 1,000 lines above. I'm just seeing it here. But what should we call this? So shader constant data. So this is going to be MIP size. That is MIP. And I'm gonna move this here. So I'm gonna construct this like so. And yeah, some other thing comes to mind here. Texture size here. Okay. What is this I? Why am I doing this conversion? Why am I doing that conversion there? I do not have a clue. Remove that, remove this one here. This code is better. Alright, and yeah, let's get back to where we came from. This here. You might say this here, since that is not the only use we have for it there, it's better to stay up there. I would probably agree with you. This comes here, and bam! Things just work. Well, we can't say they work until we actually compile this and it works. So let's call this shader constant data. Yeah, I don't know how like the Microsoft came up with this root thingy, like what it actually means, or maybe it relates to how the hardware just handles things. But maybe I don't care about the uh, I don't care about the maybe I don't care about how it works. I only care about what it means, what it does. And what it does is just passes shader constant data to the shader. That is what it does. So maybe later on, since we know the GSkyBox, maybe the compiler could like unroll this loop and all this would be compiled back. But for now we are stuck with this MIP size. And this actually speaks to me. this is telling a story here. We have MIP size, and that is the number of threads we have in one group, and this is the number of groups we want. That's that. Done. Well, let's see if it actually compiles and works. I would say it would definitely compile, but work? Who knows? And I'm also realizing that I'm just, since we have code duplicates, like we have 3 times the code, we have the code for every, we have it for DirectX, we have it for DirectX 11, we have it for Vulkan, and I just modified the DirectX version here. Same with the renderers, you have the renderers, you modified the renderers API a bit, put in some cons there. So yeah, I haven't applied those changes to the rest of the code either, but we have Git hopefully, and I will be able like to see what happened in one and just move it to the other. Hopefully that is going to work. Hopefully. Let's compile this. Let's compile and see how it actually runs. So I have like 20 minutes left from this. What is this? What was the error? Oh, we have added. I have no idea why my Visual Studio has gone so slow. It was fine earlier. So let's see. Let's see where this one is used. Only here. What about this one? Only there. So these are just remnants of our move there. Let's move them. Alright. So we've got it compiled. Let's see if it runs. So yeah, I was just saying we have 15 minutes left from this stream. If it crashes, you probably have enough time. It did crash. 9G. And down the rabbit hole we go. Oh, oh, oh. Oh crap. I know what happened. This happened. Pano to Skybox. That did happen. And of course, this could happen as well. This is a global, I believe. Let's see. Yeah, remove resource there. That's a global. So doing what I did there, like moving this here, I have access to those outside of their lifetime. Why am I scrolling so much? Confusing everyone. So let's say this here. I'm setting a barrier on that here. This access barrier here. No need for this. And what I'm doing then, is his only making that this available here. So we don't have a p texture skybox. This is not a valid pointer unless this is called, and that is our first use case, so this is not called there. I know for a fact that I can remove this. That fixes our part of our issue there. Another issue is this panel skybox, and thankfully, sorry about that. Thankfully, that is not used anywhere else. Or is it? What comes to my mind is, what is this using? What is this exactly using as input? That pipeline is an input. We have an output for it. This destination texture there. Right? What is its input? Hmm. That is weird. Why is it not failing? I mean, what is it actually computing here? Who cares? So that little cleaning up the line there, that is going to, I believe, fix that issue on that. And I'm gonna remedy that some other way later. But the more important thing for me is this one here, the Panda Skybox. That could cause issues to me. PowerShell. Thankfully I have GitK here. I'm sorry if you can't see this properly, I'm just trying to figure out like what I've changed there. So this is line 3000. Let's see if I have line 3000. Let's go about line 3000 here. Let's try to find something related to that. That is what we've added. Texture barriers, we've removed one. Target iOS. So here we should have had something maybe related to this panel skybox. But seemingly not. Seemingly we don't have anything related to that panel skybox. You guys see anything here? Panel to cube shader? No. You have good reason for removing that. Let's search here. Panel to sky. Panel skybox. P panel skybox. P panel skybox. So let's see. So yeah, this I believe I can fly. No, I don't believe I can fly. I believe this is going to be fine. Maybe. Panel descriptor. Let's check that one. Panel. All right. We should be fine. We should be fine. So that probably is fixed. Let's see if we crash. We can't be sure unless we get the code running. Let me just quick check the internet is fine and clear my throat. Here we go, guys. And we have another 10 minutes left to just like cause another crash that we can like fix tomorrow. Looks fine to me. Definitely looks fine to me. So yeah, seemingly we fixed everything. So another way of remedying the issue we just ran into was that I would return, like, it is implicit that this call here is going to write into this. That is pretty, or this, and of course the other global variable we have, but that is global. Who cares? Like, who can do any kind of guarantees on globals? And also just like, let's see, which one is this? This is the Vulkan version. Okay, let's just to make sure. Let's do this. This is just to make sure that this is what is being compiled there. I'm going to like cd. Yeah, that is telling the shader just to use half of each sides. That is disorienting a bit, at least to me. Let's remove that bit. No, all right. So we know that that is making some. So that that has a fix. And then what we're going to do is divide this by 2. This is what we did last time, just to experiment with this. And the result is as expected. I wanna see like, look at these reflections here. So you can actually see the black areas in the reflection here. That is kind of interesting. Alright, things work. Things work well. Have just a tiny bit of cleaner code. Which works as well. I do not have any kind of like uh, performance measures like recorded through these changes just to see how these actually affect the performance. This is not going to affect the performance except only to load performance, because this is done before loading. So even if it had any kind of like improvements, it wouldn't affect the FPS I would get on that or the GPU time while rendering. So yeah. Alright, let's see what else there is that we can actually take advantage of. Like, what other part of this I can make cleaner. Let's add our usual consts, and then I mean, it wouldn't be a normal day of streaming if I didn't lose connection with Bay. Thankfully, I'm back on as quick as possible. So, yeah, I was tracking down like what was happening here. So you have this panel to cube root signatures that are being set here, and you're adding descriptor sets, and the result is these. Let's see where those are used. Those are captured. So that is how I'm going to work through this. Copy these. Of course, the lifetime of these are going to be extended. That is why I would have to make these that look like that. I don't like doing so, but I believe we have to. Gonna put them here. Set descriptor. That is this one here. So we had variable mutation somewhere along the lines here. Variable mutations. You see it? Yeah, here. We are reducing the variable mutations here by like making these constants. So this is what is this? This is input descriptor set. Do I have a spell checker? I don't think I've spelled it correctly. I have. Interesting. Alright, so that has been cast there. That is going to replace that. We're copying this here. Copying this one here. And this is output. Those go there. These are our return variables. Later on I will make this a class, and these will be my members. Let me just check the connection. Connection seems fine. Yeah, these will be my members, and that is how I'm going to manage the lifetime. Like, I will probably make them smart pointers as well. So, we are at the 1 hour point. Let's finish this. Let's finish this as quick as possible. So, coming up here, where we start from. Of course, we start from the bottom. Not here, here. So this is going to move in. All right. Okay. Where is this actually? Clear. This is going to be saved, declared there. This is gonna be moved here, and that is going to be like that. So I'm not sure about the lifetime of this one there, but yeah. And this is descriptor. Its lifetime should be limited, but it probably depends on this, which is going to be copied. There we are. Skybox sampler. That is something that lives outside and is going to leave outside. My question, however, is why is it not captured by now? So this is something that everyone is using right now. Like, get your own samplers, guys. Stop using the Skybox sampler. But they're using the Skybox sampler anyway. I guess I can remedy that by That wouldn't be of much profit there. Yeah. Oh, no, 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 I'm not building. Dude, no. That is fixed there. Panel to cube shader. That right there. That is being passed to this. And where is this panel to cube shader thingy compiled? Where is it compiled? Panel to cube map shader. Okay, it is added here, but does it need a shader descriptor of this one as well? Moving it before this. I'm gonna continue until I get this to work. Well, not actually until I get this to work, because I am probably causing crashes here. I'm just gonna get a compile and that'll be it. So this is what we're looking for, which is here. That's going to be added there. This also turned into an auth variable for us. Just let's make sure nobody uses it before its lifetime has begun. Yeah, nobody uses it. That is fine. That is fine. This should work. This should work just fine. Let's check the rest of these Skybox sampler. How about that? I believe I could remove this here. Yeah, I can. The reason when I remove this ampersand here, it tells me that there's a bug here because this is modifying that, and my lambda is by default constant. That is what is causing the problem. So that is a good thing that it is causing the problem, because I am actually modifying those, and those need to actually be captured by reference rather than just a copy. And then what else do we have to check? So we made this output, that is output, this is output as well. Let's see if they are used anywhere inappropriate. No, they aren't. They are not used anywhere inappropriate. And what about this one? I believe that is not used anywhere inappropriate as well. So that is fine too. Yeah, so tomorrow I'm going to make the class. Let's compile this. Let's see if it okay, it doesn't compile. What is it saying? Okay, static sampler names. Yep, our sampler names were somewhere up here. That is my sampler names there, or is it the wrong one? That is wrong. That is the wrong one. This is the right one. Yeah, I know. You're just sitting there. Hey, you're just increasing the duplicate code. Yes, I'm increasing duplicate code. These need to be duplicate codes, unless you properly abstract them. And the code works, we didn't crash. That's that for today. Thank you for watching, and we will continue on this tomorrow. See you guys.